Hey guys, a couple of videos for you from me to watch today. The first video is going to pick up where the Mastering Chemistry videos left off. So there's two Mastering Chemistry videos for this chapter, one about ionic naming and the other about covalent naming. This PowerPoint, this section of the PowerPoint slides is going to talk about naming acids. Okay. Just real quick, a little bit about acids. They are molecular compounds, okay? So they are covalent compounds that release hydrogen ions when they get dissolved in water. We'll talk more about acids and bases later, but right now we're just going to talk about naming, okay? Typically we can identify an acid because hydrogen is, that didn't work. Hydrogen is usually written first in the formula. Okay, so it starts with H and then one or more nonmetals comes second. All right, so that's how we can identify acids based on their formula. Some characteristics of acids: they have a sour taste. Citric acid is an acid, obviously, and that's what gives citrus fruit a sour taste, oranges, lemons, things like that. Acids typically have the ability to dissolve metals, and again, their formulas start with H. So like hydrochloric acid, sulfuric acid, both of those are molecular compounds, but they're written as kind of ionic compounds, and we'll talk about that here in a sec. But they both start with H at the beginning. Okay? So here's the start of the flowchart for acids. We're going to identify it based on H being the first. If we have a binary acid, binary means 2. And so that means that there's only going to be 2 elements within this compound. One of them is going to be H, and the other is going to be some nonmetal. Okay? That's how we're going to identify those. Oxyacids have H and a polyatomic ion. Okay? So that's how we're going to differentiate between binary and oxyacids and continue on our flowchart here. So for binary acids, naming these is pretty easy. We're just going to add the prefix hydro. Then we're going to write the base of the non-metal, okay, so not the hydrogen but the other thing, and then we're going to add ic on the end, IC. So HCl. This is a binary because we have 1, 2 elements. Hydrochloric acid. That's something that you're probably familiar with. At least the name hydrochloric acid is something that you should be familiar with. And we just take chlorine and change it to chloric. We take hydrochloric acid. And that's how we name binary acids. For oxyacids, it's a little bit more complicated. It's based off of the ending on the PAI. Okay? Polyatomic ions end in ate or ite. Okay? And so if the PAI ends in ate, the change or the ending gets changed to ic for the acid. If it ends in ite, the ending gets changed to us, or OUS. Okay? Acid comes at the end, and we put ate, or we change ate to ic, and we change ite to us. So, here's some examples. This is a binary acid, because we only have 2 elements. So we have hydro. Actually, before I finish this, if you want to pause the video and solve these 3 on your own for a little bit of practice, now would be a good time to do that before I get too far. Once you come back, Now we can talk about the answers. We have hydro, and then we're going to take the base of our nonmetal, that's sulfur, and we've got hydrosulfuric acid. Okay, hydrosulfuric acid is different than just sulfuric acid. Okay, so the formulas for them would be different. Here is a oxyacid, one with a polyatomic ion. ClO3 is chlorate, so the 8 gets changed to an ic, so this becomes chloric acid. There's no hydro or anything on front of it because it has a PAI. And then this one, this PAI is acetate. Again, it's not a binary, so we don't have hydro. We change the 8 to ic, and we go from acetate to acetic acid. Okay? Boom, look at that. Hydrosulfuric, chloric, and acetic acid. So when we write the formula, when we go from name into formula now for these acids, it's the exact opposite. Okay? If we have, obviously if there's acid in the name, we're going to start the formula with an H. We're going to treat this formula as an ionic compound, even though it chemically bonds together molecularly or covalently. In order to make the formula work out right, we have to treat it as ionic. If it's a binary acid, obviously we have hydro in front. If there's no hydro, then it's going to be an oxyacid. And if we go from, for binary, we're just going to take hydro, and that means we've got hydrogen and one other thing. So we're going to take our hydrogen, and maybe it's hydrobromic acid. So we have Br for bromine. Then we need to balance charges. H is a +1, Br is a -1. So hydrobromic acid would just be HBr. Okay. If we had something with a more negative charge, -2 or -3, then we would need to put a suffix down here under our H. For oxyacids, if the ending is ic, that tells us that the polyatomic ion ends in 8. So if we have sulfuric acid, we know that it's going to be an H because it's an acid. Sulfuric tells us that we're dealing with sulfate, and so we have SO4 2-. In order to make this formula, work out, we have to have 2 of these to balance out my -2 charge here. So the formula would be H2SO4 for sulfuric acid. Same thought process follows when we go from us, this slide is not right. This is us, and this one should be ite instead of 8. Okay, but the charge balancing and the formula writing process is the same. Okay. A little bit about acid rain. Certain gas pollutants like nitrogen monoxide, nitrogen dioxide, sulfur dioxide, and sulfur trioxide can form acids when they get mixed in with water or water vapor in the air, which results in acid rain. Okay, and acid rain is obviously not a good thing. I want you to take a picture of this slide. It's got the flowchart for ionic compounds, it's got the flowchart for molecular compounds, and it's got the flowchart for acids. Okay? Take a picture of this and use it to help you study and to help you complete your homework assignments for this class, for this chapter. All right, and I think, yes, that is the end of this video. We will start with another video, and you can go watch that one too. All right, see you later.